Welcome to Math on Ice, December 2016 Integral Equations Part B and C. We see one question from Part B and two questions from Part C. The first question, that phi satisfy the integral equation, then phi of x is given by which of the following options? We solve the problem by Leibnitz rule. So the Leibnitz rule states that integral phi of x to psi of x, f of x comma t into dt, which is equal to integral phi of x to psi of x d by dx of f of x comma t into dt plus the differentiation of the upper limit into f of x comma psi of x minus d by dx of the lower limit into f of x comma phi of x. So here phi of x is equal to f of x plus the integral 0 to x sine of x minus t into phi of t dt. So I'm going to give phi of 0. Phi of 0 is equal to, we get f of 0. So this is one condition and the remaining. So phi dash of 0 we will find later. Take the differentiation with respect to the Leibniz rule. This is f dash of x plus integral 0 to x cos of x minus t into phi of t dt plus 0 and minus 0. So everything will be 0. Will be left with this. And now phi dash of 0 is equal to f dash of 0. And also again differentiating, we get phi double dash of x. Here phi dash of x. So here again differentiating, we get phi double dash of x is equal to now here differentiating, we get phi dash of x is equal to f dash of x plus integral 0 to x cos of x minus t into phi of t dt, and then applying for 0, phi dash of 0 is equal to f dash of 0. Again differentiating, we get phi double dash of x is equal to f double dash of x minus integral 0 to x. When you differentiate cos, we get sine of x minus t into phi of d dt, and then plus phi of x. So phi of x plus minus this part will be equal to plus f of x. So this is phi double dash of x is equal to f double dash of x plus f of x. Now taking integration from 0 to x, integral 0 to x, phi double dash of x into dx. So here the limit is varying from 0 to x as it is in the option. The limits are varying from 0 to x. This part cannot be x, right? So this can be taken as dt, and it is integral 0 to x f double dash of t into dt plus integral 0 to x into f of t into dt. So this will give us phi dash of x minus phi dash of 0 is equal to f dash of x minus f dash of 0 plus integral 0 to x f of t into dt. As we know, phi dash of x is equal to f dash of phi dash of 0 is equal to f dash of 0. These two cancels each other. We get phi dash of x is equal to f dash of x plus integral 0 to x f of t into dt. Again integrating with respect to t. So 0 to x phi dash of t into dt is equal to integral 0 to x f dash of t into dt plus integral both are from 0 to x f of t into dt square. So this will be f phi of x minus phi of 0, which is equal to f of x minus f of 0 plus integral 0 to x x minus t into f of t dt. As from the formula, we use this formula. Integral everything a to x a to x a to x so on a to x, this is n times, thus that will be equal to integral a to x x minus t the whole power n minus 1 divided by n minus 1 factorial into f of t dt. So here it will be f of t into dt power n. This is what present here, and we have transformed into this way, multiple integrals to single integrals. So we get phi of x minus phi of 0, and this f of 0 cancels each other. Both are equal. which is equal to f of x plus integral 0 to x minus t into uh, f of t into dt. This is present in option 1. So the first option is the correct answer. Next question, which of the following are the characteristic numbers and the corresponding eigenfunctions of the Fredholm homogeneous equation whose kernel is given by? So for the Fredholm homogeneous integral equation will be of the type y of x is equal to lambda times of integral 0 to 1. I have taken 0 to 1 because it is from 0 to 1 kernel k of x comma t into y of t dt. Here it is y of t dt. And kernel is given this way. Kernel we have to change the limit. Actually here it is x is varying from 0 to t. We need for t, right? X is varying from 0 to t means I am going to replace x by t and t by x. 0 less than or equal to t less than or equal to x will be t plus 1 into x, and then t varying from x to 1 will give you x plus 1 into t. This will be your new kernel, and this y of x will be y of x is equal to lambda times of integral 0 to x t plus 1 into x into y of t dt, and then plus lambda times of integral x to 1 x plus 1 into t into y of t dt. Now this is equal to lambda t plus 1, x can be taken outside, integral 0 to x y of t dt, and here you can take 1 plus x outside, integral x to 1 t into y of t dt, right? So this is equal to lambda x and this part integral 0 to x t plus 1 into y of t dt, and I am going to solve the problem by Leibnitz rule. Y dash of x is equal to this will be UV method. We have to take UV method and we have to take the differentiation lambda. I have taken completely lambda outside. So this will be x here. Now taking Leibniz rule differentiation, we will have this full part is independent of x. So this integral part will become 0. When you take the differentiation, partial derivative, this part will become 0. So integral 0 to x of full thing 0. Plus the upper is x here. So x plus 1 into y of x will be present. X plus 1 into y of x minus the lower is 0. So we get minus 0. And this part which is 0 to x t plus 1 into y of t dt as it is. Differentiation of this x is 1. So it is nothing. So we get this one, and then the next integral which is 1 plus x. So 1 plus x plus 1 plus x outside, and this integration will give you integral 0 to x. Whatever is present here integrand which is equal to the function which is completely of t, it is independent of x. So the integral integrand, this part when you differentiate with x, you will find it as 0. So this will be 0 plus the upper limit is actually a constant. So we get a constant differentiation as 0, and then the minus the lower limit differentiation, that is 1, and then we have this terms are replaced by x. So x into y of x plus integral x to 1, this is t into y of t dt, and differentiation of this 1 plus x will give you 1. So this is equal to lambda completely outside. This part will be x into x plus 1 into y of x plus integral 0 to x t plus 1 into y of t dt, and then plus 1 plus x minus x here. So we find minus here, minus of 1 plus x into y of x plus integral x to 1 t into y of t dt. So this and this cancels each other. So we have lambda times of integral 0 to x t plus 1 into y of t dt, and this part is lambda times of x to 1 t into y of t dt. Again differentiating y dash of x, this is right. So y double dash of x will be equal to lambda times of this part will be 0. So the upper limit is x, so we get x plus 1. So this is x plus 1 into y of x, and here we get this as x into this part will be minus x into y of x. When you solve, when you take differentiation with respect to Leibniz rule, you get this value, and that is y double dash of x is equal to lambda outside x into y of x plus y of x minus x into y of x is equal to same. So we get y double dash of x minus lambda into y of x is equal to 0. Fine. So I'm going to solve this lambda. Lambda value they have given 1 e power 1 for lambda is equal to 1. The corresponding eigenfunction should be e power x or not. So this lambda, when you write the auxiliary equation of this one, we get m squared minus lambda is equal to 0. When lambda is greater than 0, that is lambda is equal to mu squared. If I take this so, I get m squared minus mu squared is equal to 0. I get m is equal to plus or minus mu. So I will have y of x is equal to a e to the power mu x plus b e to the power minus mu x. Yes, from these conditions, we can also derive one more thing. Y of 0, what is y of 0 here? We'll take boundary condition. Y of 0 is equal to, when you apply y of 0 here, you will find this limit is 0 to 0. So this integral part will become 0. This will be lambda times of integral 0 to 1. When you put x is equal to 0, we get t into y of t dt. And then y of 1. If you put y of 1, then this integral will vanish and you will be left with only this. So it is integral 0 to 1 t plus 1 into y of t dt, right? So that will give you, and this one will give you y dash of 0 is equal to, again this part will become 0. You'll be left with lambda times of integral 0 to 1 t into y of t dt. And y dash of 1 will give you lambda times of integral 0 to 1 t plus 1 into y of t dt. When you see here, y of 0 and y dash of 0 both are same, and y of 1 and y dash of 1 are both are same. So we get the boundary condition y of 0 is equal to y dash of 0 and y of 1 is equal to y dash of 1. Now applying this here, we get y dash of x, right? So we need y dash of x is equal to a mu e to the power mu x minus b mu e to the power mu minus mu x. Y of 0 is equal to y dash of 0. Y of 0 is equal to a plus b, and y dash of 0 is equal to a mu minus b mu. So these are equal. So from this we get a times 1 minus mu plus b times 1 plus mu is equal to 0. This is one equation. And from the second, y of 0, y of 1 is equal to y dash of 1. Y of 1 will give you e to the power a into e to the power mu plus b into e to the power minus mu, and that is equal to a mu e to the power mu minus b mu e to the power minus mu. So when you take a outside, you will be left with e power mu minus mu e power mu, and this is b e power minus mu minus will give you plus mu e to the power minus mu, which is equal to 0. So you can have this in the matrix form and solve. So we have 1 minus mu here, 1 plus mu here. This is e power mu outside, 1 minus mu, and this e power minus mu outside, 1 plus mu. First column has 1 minus mu common, so 1 minus mu can be taken outside. Second column has 1 plus mu common, so 1 plus mu outside. We'll have 1 e power mu e to the power minus mu, which is equal to this. We get 1 minus mu squared. This we get e to the power minus mu minus e power mu is equal to 0. Either this is 0 or this is 0. If the first part 1 minus mu squared is equal to 0, we get mu squared is equal to 1. We get mu is equal to plus or minus 1. Okay, now this part e to the power minus mu minus e power mu is equal to 0. That implies e to the power 1 divided by e power mu minus e power mu is equal to 0. We get 1 minus e power 2 mu is equal to 0. And this implies e power 2 mu is equal to 0. Taking log on both the sides, we get e power 2 mu will become log e, and log cancels each other. 2 mu is equal to log 1 is 0. So mu is equal to 0. Mu is equal to 0 is not a possible case because lambda greater than 0 we have taken. So mu will be obviously greater than 0. So this is not a possible case. Only mu is equal to plus or minus 1 is the only possible case. Mu is equal to plus or minus 1. When we take mu is equal to 1, what will happen? Mu is the mu squared. Lambda is equal to mu square, so that will be 1 always. So lambda is equal to 1 when lambda is greater than 0. So lambda is equal to 1. This is a possible case. And we have to find the corresponding eigenfunction. when lambda is equal to 1, and that is mu squared is equal to 1. Let me take mu is equal to 1 in this first equation. This is second equation. When mu is equal to 1, what will happen? What will happen to this condition? This a part will go off, so we'll be left with 2b is equal to 0. That will imply b is equal to 0. When you put mu is equal to 1 here, we get b is equal to 0. And a is arbitrary. So the corresponding eigen function y of x is equal to a e to the power mu x will be present, and this b part will be 0. So we get a e to the power mu x. Y of x is equal to a e to the power mu x. Mu is actually equal to 1, right? So we get a e to the power x. A is any arbitrary constant, so this is a possible case. 1 and e power x. First one is true. And for second one, when you see the eigen functions, they are all in terms of cos and sine. So I'm going to take this lambda is less than 0. When lambda is less than 0, I'm going to take lambda is equal to minus mu squared. So we have y double dash of x plus mu squared into y of x is equal to 0. So in this equation, I have put instead of lambda, I have substituted minus mu squared. So this implies m squared plus mu squared is equal to 0. That implies m squared is equal to minus mu squared. That implies m is equal to plus or minus I mu. So I'll have y of x is equal to a cos mu x plus b sine mu x, right? So this will give me y of 0, which is equal to, I'll find y dash of x, which is equal to a mu minus sine mu x plus b mu cos mu x, and this y of 0 will give you cos 0 is 1, so this is simply a, and y dash of 0 will give you sine 0 is 0, so this will give you b mu. Both are equal. A is equal to b mu, and y of 1 is equal to a cos mu plus b sine mu here, and this part y dash of 1 will give you a mu sine mu here, negative, minus a mu sine mu, and then b mu cos mu. Here we have a minus b mu is equal to 0 is one equation, and the second equation would be a outside cos mu plus mu sine mu will be here, and then plus b times of sine mu minus mu cos mu is equal to 0. This is your second equation. Now using matrix we solve the problem. So this is 1 here, this is minus mu here, and cos mu plus mu sine mu, and then here sine mu minus mu cos mu, So take the determinant. We have sine mu minus mu cos mu, and this part is plus mu times of cos mu plus mu sine mu is equal to, we get sine mu, this is actually equal to 0 right side, sine mu minus mu cos mu plus mu cos mu plus mu squared sine mu is equal to 0. These two cancels each other. Sine mu can be taken outside. So we have 1 plus mu squared is equal to 0. Either this is 0 or this is 0. If 1 plus mu squared is equal to 0, then what will happen? Mu squared is equal to minus 1. So mu is equal to plus or minus I. Right, if mu is equal to 1 plus mu squared is equal to 0, mu squared is always positive because we have taken mu squared which is lambda, which is strictly less than 0, which is not equal to 0. So this must be 1 plus mu squared is always positive. Always positive number can never be equal to 0. So this is actually an impossible case. Only sine mu is equal to 0. We get mu is equal to n pi. When mu is equal to n pi, what about lambda? Lambda is equal to mu squared, that is minus mu squared here, which is equal to minus n squared pi squared. So this is what our lambda is. Let me take n is equal to 1 for the second option. So for second option has minus lambda squared, it seems. Yes. So let me take n is equal to 1. If I take n is equal to 1, then what happens? Lambda is equal to minus pi squared, and mu is equal to pi will be there. So if I substitute in the first equation, when I substitute mu is equal to pi here, then I'll have a minus b pi, that is equal to 0. I'll get a is equal to b pi. So I'll just substitute this in this y of x is equal to a cos mu x plus b sin mu x. This is the solution. Y of x is equal to a cos mu x plus b sin mu x, right? So here y of x is equal to, a is actually b pi cos pi x plus b sine pi x. So taking b outside, we have pi into cos pi x plus sine pi x. So pi into cos pi x sine pi x is the corresponding eigenfunction. So here pi into option 4 is true and the second option is false. We have to verify the third option when n is equal to 2. When n is equal to 2, we get n is equal to 2 means we get lambda is equal to minus 4 into pi squared. So mu is equal to n pi, that will give you 2 pi. Again, a is equal to b mu, right? So that implies a is equal to b into 2 pi. The corresponding function is y of x is equal to a cos mu x plus b sine mu x. So that will give you a is actually 2 pi b into cos 2 pi x, and then this part b into sine 2 pi x. So this is equal to b can be taken outside, 2 pi into cos 2 pi x plus sine 2 pi x is the corresponding eigenfunction. For lambda is equal to minus 4 pi square, but here in the option we don't have the corresponding. This is the correct lambda, but for this lambda this is not the eigenfunction, so third option is wrong. Only the option first one is true and the last option is true. The integral equation phi of x minus 2 by pi integral 0 to pi, yes. So phi of x is equal to f of x plus 2 by pi integral 0 to pi cos of x minus t into phi of t dt. We need to find how it has infinitely many solutions if for f of x. So we have to check by option by option. Now we solve the problem by the method Ax is equal to b, and we will just find the matrices A, B, and then we will evaluate whether it has infinitely many solution if f of x takes the corresponding functions. Right. So here lambda is equal to 2 by pi and kernel k of x comma t is equal to cos x cos t minus sin x sin t. Let me take this as alpha 1, beta 1, alpha 2, beta 2. And this matrix A matrix is equal to 1 minus lambda A11 and then minus lambda A12 minus lambda A21 1 minus lambda A22, where Aij is equal to integral A to B beta I of x into alpha j of x into dx, and the matrix B will be equal to V1 V2, where V1 is equal to integral A to B f of x into beta j of x into dx, and v2 is equal to that is vj, let me take it as vj itself, beta j of x into dx. Now we will solve one by one. We will find a11 which is equal to integral 0 to pi beta 1 is actually cos x, alpha 1 is cos x, so we get cos squared x into dx which is equal to integral 0 to pi 1 plus cos 2x divided by 2 into dx, we'll get it as pi by 2, and a12 will be equal to integral 0 to pi minus cos x into sin x into dx which is equal to 0, and then a21 is equal to integral 0 to pi sin x into cos x which is equal into dx is equal to 0 again, and then when you find a22 is equal to integral 0 to pi minus of sin squared x dx which is also equal to pi by 2. Hence, the matrix A will be equal to 1 minus lambda is actually equal to 2 by pi, right? So, lambda is equal to 2 by pi. So, 2 by pi into this part is pi by 2 and this is 0, 0, and then this is 1 plus 2 by pi into pi by 2. So, we get it as 0, 0, 0, 2. This is our matrix A. Now we need to find the matrix B. B matrix will be equal to V1, V2. So for the first option, f of x is equal to cos x. Let me take the first option. F of x is equal to cos x. Now for this option, integral 0 to pi, V1 will be equal to cos x into, what is our beta 1? Beta 1 is equal to cos x. So here it is cos x into dx. So we get integral 0 to pi cos squared x into dx which is equal to pi by 2. And then v2 is equal to integral 0 to pi cos x into sin x into dx. So we get it as 0. Right, so V1, V2, we got it as the matrix A is equal to 0, 0, 0, 2 and rank of A is equal to 1. And this matrix A by B, augmented matrix 0, 0, 0, 2 over pi by 2, 0. It is having rank of A by B which is equal to 2. Both of them have different ranks. So this will not be a case for infinitely many solutions. So first option is false. So this is false. So for f of x is equal to cos 3x, we have integral 0 to pi, that is v1 is equal to cos 3x into cos x into dx, and this is equal to 0. As cos mx into cos nx is equal to 0 when m not equal to n. And v2 is equal to integral 0 to pi cos 3x into sin x into dx. So this is equal to integral 0 to pi 1 by 2 outside sine of 3x plus x, that is equal to 4x minus sine 2x sine of a minus b. So this is a direct formula. 2 cos a sine b is equal to sine of a plus b by a plus b minus sine of a minus b, the whole thing divided by 2 into dx. So this will give you, which is equal to 1 by 2 into integral 0 to pi sine mx and 0 to pi sine nx. This will give you 0 because it is cos 4x divided by 4 minus, I am taking it outside. So when I take outside, this will be minus cos 2x divided by 2. This is from 0 to pi. When you apply the limit, it is equal to 0. So we get 0, 0, 0, 2 and the argument matrix is 0, 0 completely, and it has rank of A is equal to 1 and which is equal to rank of A by B. So this option is true. It has infinitely many solutions. So the second option is true. F of x is equal to sin x. For f of x is equal to sin x, we have v1 is equal to integral 0 to pi sin x into cos x into dx is equal to 0, and v2 is equal to integral 0 to pi sin x into sin x dx is equal to sin squared x, which is equal to pi by 2. So we get the matrix 0, 0, 0, 2, 0 pi by 2. It has a rank of A is equal to 1 and which is equal to rank of A by B. So we get both of them having same rank, which is equal to infinitely many solution. So this option is also true. F of x is equal to sin x. So if you also find f of x is equal to sin 3x, for f of x is equal to sin 3x, we have integral 0 to pi v1 is equal to sin 3x into, we get cos x into dx. So this is equal to integral 0 to pi sin a cos b is equal to 1 by 2 into sine of a plus b, that is sine 4x minus sine 2x into dx. When you solve, you get this to be 0, right? So, and v2 is equal to integral 0 to pi sine 3x into sine x into dx. So we have here mx, nx, both m and n are not equal, so it is equal to 0. So eventually this will also give you 0, 0, 0, 2 and 0, 0, that is implying us rank of A is equal to 1, which is equal to rank of A by B, therefore infinitely many solutions. So B, C, D, last three options are true. First option is false. Thank you.